Let us understand in details what is prime factorization, how do we write a number as a product of prime factors, how do we find total number of factors for a given number, and also what are actually those factors. All this in this video with Anil Kumar. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll discuss three issues. First, we'll find the number of factors for the given numbers. I've selected three numbers 36, 32, and 540. And then, once we find number of factors, we'll find all the factors of the numbers. And all this will be done using prime factorization. So we'll learn prime factorization. After writing the prime factors, we'll write down how many factors can we have, and then we'll confirm by writing all the possible factors. Interesting? So that is what we are going to do. Three examples 36, 32, 540 are the numbers with very special characteristics which we'll explore as we move along. Let me also thank all the viewers and subscribers for watching my videos, posting excellent comments and suggestions. This video is a request from one of our subscribers. So now let us understand what is prime factorization with the very first example. So I'm taking 36 as a very simple number to work with, right? So prime factorization means you should divide this by prime numbers like 2, 3, 5 and all, right? So you can divide by 2. Once you divide by 2, 2 times 18, is 36. 18 being even, you can further divide by 2, you get 9. And 9 is 3 times 3, correct? So this process which we just did is called prime factorization. Now from prime factorization, we can actually write the number 36 as also equal to product of its prime factors. So we know it is like 2 times 2 times 3 times 3, or we could write this as 2 square times 3 square, right? So either way you could write, the decimals here are not the decimals, they are the product multiplication signs, okay? So 36 is 2 times 2, which is 4. 4 times 3 is 12. 12 times 3 is 36. So once you multiply all these numbers, you get the original number, which can be written in the exponential form. Now, here is a formula. How do we find number of factors now? So we'll find number of factors from here, which is 2 to the power of 2 times 3 square, right? So the number of factors will be, see, how many times can you use 2 when you multiply a number? There are two 2's, right? So you have a choice. Either you select one 2, or you select two 2's, or you do not select any 2. You get the whole idea. So the number of choices will be 2 plus 1, right? And with 3 also, you may select 1 3, 2 3, or no 3 at all. So here also we got 3 choices, correct? So we see 2 plus 1 is 3, and 3 times 3 is 9, right? So number of factors are 9, right? Are 9. So we found that total number of factors are 9 for 36. Now, what are these factors? Well, rainbow is what you know, right? So we can do 36 with a rainbow. So let's find now the factors. So as far as 36 is concerned, 1 times 36 is 36, correct? 2 times what? 2 times 18 is 36. 3 times what? 3 times 12 is 36. And 4 times 9, correct? And then 6 times 6, so 6. You see, these are all the factors. So at times you had been doing this factor rainbow, right? So which is like 2 times 36 is what you get, and 2 times 18, 1 times 36, correct? 3 times 12, 4 times 9, and 6 with itself is a perfect square. Since the number is a perfect square, we have odd number of factors. You notice that also. Correct. Now, we will understand how do we get these numbers from the prime factors. That is, how do we get all these numbers using 2, 2, 3, and 3. Now, as far as 2 is concerned, see, it is using only 1, 2, right? When 3 is used, we use 3, just 3, right? What is 4? 4 is 2 times 2, right? So we use two twos. And 6, how do we get? 6 is 2 times 3. 9 is 3 times 3. And 12 is what? 2 times 2 is 4, and 4 times 3 is 12. You get the whole idea, right? And when the 18 comes, in that case, we multiply 3 times 3 with 9, right? And 9 times 2 is 18. And 36 is, of course, you have to multiply them all when you take them all, right? You understand? How do you get 1? 1 means you do not get any 0, 2 to the power of 0. You don't take any 2, nor do you take any 3. Anything to the power of 0 is 1, and 1 times 1 is 1. So that is how you get 1. Now you understand how only with prime factors we could get our result, right? Anyway, we have seen prime factorization, number of factors, listed all the factors, using this process and connected it with what you already know, which is a rainbow to write down the factors. Now we'll further explore with the next example. So the next example here for us is 32. So if I do prime factorization of 32, I get what? 2 times 16 is 32. 2 times 8 is 16, 2 times 4 is 8, and 2 times 2 is 4. So we get all these 2. So I could write 32 as 2 to the power of 1, 2, 3, 4, 5. So when you can write this as a prime factor, which is basically 32 is equal to 2 times 2 times 2 times 2 times 2. 5 twos when you multiply, you get 32. Now, which I wrote as exponential form 2 to the power of 5. So now from here, can you tell me how many factors do you expect? Yes. There's only one factor, prime factor, and number will be 5 plus 1, which is 6. Do you see that? Now, let us write down how do we find these 6 factors. I can actually still make a rainbow tree, but now I will teach you the method of finding the factors. So let's find the factors and we'll use a strategy. So we could have 1, 2, only 1, 2, right? So that will give us one factor. We can have two twos, correct? So that is the next factor. We can have 3 twos. So 8. We can have 4 twos, which is 16. We can have all the twos, right? You see that. And we have nothing. That is, we write 2 to the power of 0. 0 means no 2, which is 1. Anything to the power of 0 means if you don't take anything, then 1 is always a factor. You know, 1 is always a factor, right? So we get our factor 1, 2, 4, 8, 16, 32, and you can count, they are 6 in number, right? Correct? So if you were to draw a factor tree for 32, you will do like this, right? You say 1 times 32, correct? 2 times 16, correct? And then you say 4 times 8, correct? So you got 6 factors. Makes sense, correct? So 1 times 32, 2 times 16, 4 times 8. So you got this factors using rainbow, and this is the factors using the choices. How many twos can you take? You take 0, 2, none of them, we'll get 1 as a factor. 1, 2, we'll get 2 as a factor. You get the whole idea. Now we come to our real question, which is 540. So I purposely taken a big number because now if you make the rainbow tree, you may miss out on some numbers, correct? Great. Let's now figure out how do we do prime factorization for a number like 540. So what I will do is first I will divide it by big numbers and then split them. So 540, we can say 54 times 10. I know these are not prime numbers, but we can split them further as prime numbers. But this was a easy case of division, right? And 54 is what? 6 times 9, right? 6 times 9 is 54. And 10 we know is 2 times 5. So I'm showing you a strategy of prime factorization for big numbers. So you can actually start with big numbers and then end with all the prime numbers. Now 6 can be written as 2 times 3, right? 9 can be written as 3 times 3. 2 and 5 are already prime factors. So that means I can now write 540 as equal to, how many 2's do we have? We have 2 2's, right? How many 3's? 3 3's, correct? And there's one 5. Do you see that? So we get 540 as 2 square times 3 cube times 5. So that is our prime factorization. Now the second question, which is how many factors do you expect? Can you tell me that now? So pause the video, write down how many factors of 240. So 540. So 540 is equal to 2 square 3 cube times 5. So the number of factors will be 2 plus 1, 3 plus 1. If nothing is the power, that means 1 is the power, right? So 1 plus 1. A choice of taking a 5 and not taking a 5. Makes sense, right? So we get 3 times 4 times 2, which is 3 times 4 is 12. 12 times 2 is 24. So we expect 24 factors of 540. You get the whole idea. 24 factors. Now, let us write down all the 24 factors of 540 on the next page. Correct. So, we'll begin with 540, which is equal to, we got 2 2's, right? 3 3's, and we got 1 5. So, that gave us 540, correct. 27 times 4 times 5 is 540, correct. Great. Now let's see. How do we find the factors, correct? So always when you begin with, when you multiply none of them, you always get 1 is a factor, right? 1 is always a factor, correct? And 540 is always a factor. That means you multiply them all, you get 540. Now, we have decided that 1 and 540 is done for us, right? So we have 1 and 540. Now let's look into the other factors. Okay, so let's see this strategy. Let's begin with 2 first. So now with 2, what can I do? I can take 1 2, correct? Or I can take 2 2's, correct? So that gives me 2 as a factor. This gives me 4 as a factor. Now let's take 3. I could take 3 as a factor. That gives me 3. I can take 2 3's, right? Which is 9. Or I could take all 3 3's, correct? Which is 27. Is that okay? Now, and 5 alone will give me 5. So these are the factors when I'm taking the numbers by themselves, right? Now let's look into the combinations, right? For example, with 1 2, I could take 1 3, correct? I could multiply 1 2 with 1 3, correct? Which means 6 is a factor. I could multiply a 2 with 2 3's because I have 3 of them, correct? So 9 times 2, 18 is a factor. I could multiply 1 2 with 3 3's because I got 3 3's, right? 27 times 2 is 54. Makes sense. Similarly, I could do all that multiplication with two 2's. So I could have two 2's times 3, which will give me 6 times 2, 12. I could have two 2's times 3, which is 36. And I can get two 2's with 3 times 3 times 3. Correct? And that gives me double of 54, which is 108. You see that? So what I'm doing is all the factors I'm taking one by one. So I've taken combination of 2's with 3's. I can now also take combinations of 2's with 5's, right? 2's 2, 3, and 5. Let's take 2, 3, and 5, and then we'll take 2, 3. So with 2, 3, and 6, I could also take 2, 3, and 5, right? That means 6 times 5, 30. With this number also, I can multiply this to 5, right? Do you see that? So we get 18 times 5 as our next factor. 5 times 8, 40, 90, right? And with this number also, which is 2 times 3 times 3 times 3 times 5, right? So 27 times 10, right? 270. Then with two twos, 3, and also 5, right? 60. So I'm multiplying 12 by 5, basically, right? So two twos, three threes, and with also 5, right? So I'm multiplying this by 5. 5 times 6 is 30. 3, 5 times 3 is 1580. This number also I'll multiply by 5. That is to say 108 times 5, right? Correct. So 8 times 5 is 40, so 540. That is our last factor. We have taken all together. Is that clear to you? So we have seen all these numbers. Now look here. We could do 3's with 5's, which we have not done so far, right? So the combination of 3's with 5 has not been done. So let's do that, right? So we could have 1 3 with 5. Let's do it here, right? Okay. So 3 with 5 gives us 15, correct? And then 2 3's with 5 will give us 45. And then 3 3's with 5. Multiply this by 3 again. 3 times 5, 15, and 12, 135. You get the idea. So we have taken one by one all the combinations, right? We took just numbers itself. We took multiples of 2 with 3 and then with 5. One more combination I think is left, which is multiplying 2 with 5, right? So let's do that. So 2 times 5 is 10. There are two 2's, so we could also get that, which is 20. Makes sense. Is there anything else which is left? I don't think so, right? So now let's count, right? So of course, we'll always begin with 1. And since we have 540 at the end, let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So we have all the 24 factors. Do you understand? We predicted 24. Why we predicted one more than this, right? So we predicted that it should be 2 plus 1 times 3 plus 1 times 1 plus 1, correct? Which is 3 times 4 times 2, which is 24. So you see how we predicted and also got each and every factor, and this is the process of getting them. It is laborious, but it is foolproof, right? If you do the factor tree also, you'll have to make a huge rainbow, right? And then get it. But this is a very good method of finding all the possible factors. Most of the time, we are interested in number of factors, right? So we can also find number of factors without really getting into the details of what are the factors. So I hope it all makes sense. Feel free to write a comment, share your views. If you directly want to learn from me, send an email on globalmathinstitute@gmail.com. We are also looking forward for your contributions. We have been always providing you absolutely free, useful videos, and this quality education now needs your support. Worldwide, we are actually providing services to more than 80 countries, and if you support, we can do a much better work in our passion of supporting quality education. So, looking forward to your contacting us and supporting. Thanks for your time and all the best. A request from Anil Kumar. Feel free to support our channel whenever possible. Thank you and all the best.